Now, in the previous session, we looked at the series expansion for sine and cosine. Now, let's look at the series expansion for tan alpha. We have already seen sine alpha is equal to alpha minus alpha cube by 3 factorial plus alpha to the power of 5 by 5 factorial minus and so on. And similarly, for cos alpha, we have 1 minus alpha square by 2 factorial plus alpha to the power of 4 by 4 factorial minus alpha to the power of 6 by 6 factorial plus and so on. Now, since tan alpha is an odd function, the series would contain only odd powers of alpha. So let us say tan alpha is equal to a sub 1 alpha plus a sub 3 alpha cube plus a sub 5 alpha to the power of 5 and so on. Now, we have to find a sub 1, a sub 3, a sub 5 and so on, the coefficients. Now, we know tan alpha is equal to sine alpha by cos alpha, which implies tan alpha times cos alpha is equal to sine alpha. So, in this, let us substitute these expansions. We get a sub 1 alpha plus a sub 3 alpha cube plus a sub 5 alpha to the power of 5 plus and so on times 1 minus alpha square by 2 factorial plus alpha to the power of 4 by 4 factorial and so on is equal to the series expansion for sine. Equating the coefficients, we get coefficient of alpha is equal to, now we by multiplying these two series, the only way in which we can get alpha is by multiplying a sub 1 alpha with 1. By multiplying any other terms, we will not get alpha. And on the right hand side, alpha has the coefficient 1. So a sub 1 is equal to 1. Now let's look at alpha cube. So alpha cube we will get when we multiply a sub 1 alpha times minus alpha square by 2 factorial. And alpha sub 3 alpha cube times 1. So which means a sub 3 minus 1 by 2 factorial. That is 2. So a minus a sub 1 by 2 is equal to, and on this side we have minus 1 by 3 factorial, that is 1 by 6. So we have a sub 3 minus a sub 1 by 2 is equal to minus 1 by 6. Now a sub 1 is 1. So we get a sub 3 minus 1 by 2 equal to minus 1 by 6. And evaluating for a sub 3, we get a sub 3 equal to 1 by 3. Similarly, coefficient of alpha to the power of 5 is a sub 5 minus a sub 3 by 2 plus a sub 1 by 24 equal to 1 by 120. Now here we know a sub 3 is 1 by 3 and a sub 1 is 1. So only variable is a sub 5, or rather the only unknown is a sub 5. So evaluating for that, we get 2 by 15. So which means tan alpha is equal to a sub 1 alpha plus a sub 3 alpha cube plus a sub 5 alpha to the power of 5 and so on. And here we substitute a1, a3, a5. To get a1 is 1, so alpha plus a sub 3 is 1 by 3. So alpha cube by 3 plus here we have a sub 5 alpha to the power of 5. A sub 5 is 2 by 15. So we have plus 2 by 15 alpha to the power of 5 and so on. Similarly, we can figure out the series expansions for sec alpha, cosec alpha and cot alpha. So what we have achieved is figuring out the series expansion for tan alpha by using the series expansions for sine alpha and cos alpha and equating the coefficients. If you found this session helpful, please do like, share, and subscribe. Comment suggestions are always welcome. Thanks for watching. See you in the next session. That's it for now.